Hey there, Zerners! Today, we're builders. We'll use this centimeter grid paper and these centimeter cubes to help. Let's get started. This is the foundation of our building, 4 square units. Now, I'll place 4 cubes directly on top of the square. This represents the ground floor of our building. You try. I'll make a second floor by putting another 4 cubes on top. Your turn. Update your building so that it matches mine. How many cubes are there now? Now there are 8 cubes. The ground floor stayed the same. We built one more layer of 4 cubes on top of it, so the second layer of cubes makes the solid taller. Let's add one more layer. What is the total number of cubes now?
We started with 4 unit cubes in the first layer. Then we added 4 more in the second layer. That's 8 cubes. Then we added 4 more in the third layer. 8 plus 4 equals 12 cubes.
I also got 12 cubes. Since there are 3 layers with 4 cubes in each layer, I thought of it as 3 times 4 equals 12.
That's right. Let's take a closer look at our unit cube. Let's measure the dimensions. The length is 1 centimeter. The width is 1 centimeter. And the height is 1 centimeter. Each edge of the cube measures 1 centimeter, so we call this a cubic centimeter. We can also write it like this. We use cubic units, like cubic centimeters, to measure volume, the amount of space an object takes up. What is the volume of this solid? 2 cubic centimeters. What is the volume of this solid? The volume is 4 cubic centimeters. Now, let's build a different structure with a volume of 4 cubic centimeters. Each of these shapes has a volume of 4 cubic centimeters. No matter how we arrange the 4 cubes, the volume stays the same. Ah, I can see our building now. Let's keep going. This time, we'll use our notes. Today, we're working on Mission 5, Lesson 1. We'll start by drawing 1 cubic unit. I'll connect 4 dots to make a parallelogram. This will represent 1 square face of the cube at an angle. Your turn. Next, I'll draw 3 straight line segments to the right from the 2 vertices on the top and the 1 on the bottom right. Give it a try. Finally, I'll draw 2 segments to represent the missing edges. Now we have drawn 1 cubic unit. You try. Now let's draw 2 cubic units. Connect 4 dots to make a parallelogram just as we did before. Then add another parallelogram that shares its right edge. Next, draw 4 straight segments to the right from the 3 vertices at the top and the one on the bottom right. Finally, draw 3 line segments to represent the missing edges to complete your shape. Now we have 2 cubic units. Nice work drawing cubic units. Are you ready for a challenge? What's the volume of this shape? Each layer has 8 cubic centimeters, and there are 2 layers. 8 times 2 equals 16, so the volume is 16 cubic centimeters. Great job building shapes and calculating volume today, Builder. Keep it up. Hey there, Zernstar. Let's jump in. What is the volume of this rectangular prism? This prism's volume is 4 cubic centimeters. I'll add another layer of 4 cubes like this. What is the volume of this prism? 8 cubic centimeters. Now I'll add 3 more layers of 4 cubes. Take a look at this prism. How many cubes are in each layer? There are 4 cubes in each layer. How many layers did we build in all? We built 5 layers. We know each layer has 4 cubes. So, what's the volume?
We can add each layer to find the volume. 4 cubic centimeters added 5 times equals 20 cubic centimeters.
We can also multiply 4 cubic centimeters times 5. That's 20 cubic centimeters.
That's right. Let's record this in a table. There are 4 cubic centimeters in each layer and 5 layers. The volume is 20 cubic centimeters. Let's look at these layers in a different way. This time, we'll change the colors to show 2 horizontal layers. Let's make this top layer orange. How many cubes are in each layer now? There are 10 cubes in each layer and 2 layers. What's the volume?
10 cubic centimeters plus 10 cubic centimeters equals 20 cubic centimeters. And 10 cubic centimeters times 2 equals 20 cubic centimeters.
Exactly. Let's record this in our table. This time, we can see 10 cubes in each layer and 2 layers. Complete the table. I'll record 20 cubic centimeters in our table here. Let's switch it up one more time. This time, let's make this layer orange. How many cubes are in each layer now?
There are 10 cubes in each layer, and there are 2 layers. 10 cubic centimeters plus 10 cubic centimeters equals 20 cubic centimeters. And 10 cubic centimeters times 2 equals 20 cubic centimeters.
Yes. Complete the table to match this prism. We found the same volume each time, 20 cubic centimeters. We just looked at the prism 3 different ways. Let's try another one. What's the volume of this rectangular prism? The volume of this prism is 9 cubic centimeters. Let's build another layer. What's the volume of the prism now? Now we have 18 cubic centimeters. Let's build one more layer. What's the volume now? 27 cubic centimeters. Now, complete the table to match this prism. There are 9 cubes in each layer, and there are 3 layers. 9 cubic centimeters times 3 equals 27 cubic centimeters. Now let's look at this prism another way. We still have 9 cubes in each layer and 3 layers, so our volume is still 27 cubic centimeters. One more time. 9 cubes in each layer, 3 layers. The volume is still 27 cubic centimeters. This prism is a cube. Great effort so far, Zernstar. Let's try this next one in your notes. Today, we're working on Mission 5, Lesson 3. Check out this prism. Let's decompose it into horizontal layers here to help us solve. We can see 5 horizontal layers in this prism, so I'll draw lines to partition this prism into 5 horizontal layers. You try. Now, let's label each layer. We can see that there are 4 rows with 3 cubes in each row. So, each layer has 12 cubic centimeters. I'll write 12 in each layer like this. Your turn. How many cubes are in each layer? How many layers? Record this in the table. There are 12 cubes in each layer and 5 layers. So, what's the volume of this prism? There are 12 cubes in each layer and 5 layers, so we can multiply 12 cubic centimeters by 5 to solve. 12 cubic centimeters times 5 equals 60 cubic centimeters in total. So the volume of this prism is 60 cubic centimeters. Check your work. Let's partition this prism another way. This time, we'll decompose it into vertical layers here. We can see 4 vertical layers in this prism. So, I'll draw lines to partition this prism into 4 vertical layers. Your turn.
Draw lines to partition this prism into 4 layers.
Now, label the number of cubes in each layer on the prism. Use this drawing to help. We can see in this prism that there are 15 cubic centimeters in each layer. Now, record the number of cubes in each layer and the number of layers in the table. There are 15 cubic centimeters in each layer and 4 layers. What is the volume of this prism? We can multiply 15 cubic centimeters by 4 to solve. That's 60 cubic centimeters. So the volume is 60 cubic centimeters. Check your work. One last time. Now, we'll decompose this prism into 3 vertical layers here. We can see 3 vertical layers in this prism, so I'll draw lines to partition this prism into 3 layers like this. Your turn. Draw the lines, then label the number of cubes in each layer here, here, and here. There are 20 cubes in each layer. Now, complete the table to match this prism. There are 20 cubes in each layer, and there are 3 layers. 20 cubic centimeters times 3 equals 60 cubic centimeters. So, the volume is 60 cubic centimeters. We found the same volume each time. We just partitioned the prism in different ways. Check your work. Great work today finding the volume of prisms by partitioning them into different layers. Keep practicing. Hey there, Zernstar! Check out this rectangular prism. Build it on your own. Let's look at the layers one way. Here's our table. Instead of finding the number of cubes in each layer, let's record the dimensions of each layer. Each layer is an array, 3 cubes by 2 cubes, and there are 4 layers. What's the volume?
Each layer is 3 cubes by 2 cubes, which is 6 cubes. 6 cubes times 4 layers is 24 total cubes. So the volume is 24 cubic centimeters.
That's right. Let's look at the layers a different way. Now, each layer is 4 cubes by 2 cubes, and there are 3 layers. We know that the face of each cube is 1 square centimeter, and there are 8 cubes that make up this face of the prism. Write a multiplication expression we can use to find the area of this face. The area of this face is 4 centimeters times 2 centimeters. We know that's 8 square centimeters, but I'm going to leave it as 4 centimeters times 2 centimeters for now. And there are 3 layers behind this face. That's the same as the length of the prism, 3 centimeters. Multiply the area of the face by the length to find the volume of the prism. We know 4 centimeters times 2 centimeters equals 8 square centimeters. 8 square centimeters times 3 centimeters equals 24 cubic centimeters. So 4 centimeters times 2 centimeters times 3 centimeters equals 24 cubic centimeters. Let's try this one more time. Now, each layer is 3 cubes by 4 cubes, and there are 2 layers. Write a multiplication expression we can use to find the area of this face. The area of this face is 3 centimeters times 4 centimeters. That's 12 square centimeters. This time, there are 2 layers behind this face. That's the same number as the width, 2 centimeters. Multiply the area of this face by the width to find the volume of the prism. 3 centimeters times 4 centimeters is 12 square centimeters. And 12 square centimeters times 2 centimeters equals 24 cubic centimeters. So 3 centimeters times 4 centimeters times 2 centimeters equals 24 cubic centimeters. We already knew we could count the number of cubes to find the volume, but this time we multiplied the area of one face by the number of layers to find the volume. Did you notice a pattern in our equations? We multiplied all 3 dimensions, just in a different order. Multiplying the 3 side lengths together, 3 centimeters, 2 centimeters, and 4 centimeters in any order will give us the correct volume, 24 cubic centimeters. This is true for any rectangular prism. Let's use this strategy to find the volume of this rectangular prism. This rectangular prism is built from centimeter cubes. What are the dimensions of this prism? This prism has a length of 3 centimeters, a width of 2 centimeters, and a height of 3 centimeters. You could have named the length, width, and height in a different order, depending on how you look at the prism. We could multiply the dimensions to find the volume of this prism. Go ahead and solve. 3 centimeters times 2 centimeters times 3 centimeters equals 18 cubic centimeters. You could have multiplied in any order, as long as you multiplied all three dimensions. Let's solve this next one in your notes. Today, we're working on Mission 5, Lesson 4. This rectangular prism is built from centimeter cubes. What are the dimensions of this prism? This prism has a length of 4 centimeters, a width of 2 centimeters, and a height of 2 centimeters. You could have written these dimensions in any order, depending on how you looked at the prism. Check your work. Now, write an equation to find the volume. Make sure to include the units. Record the volume here. We can multiply 4 centimeters by 2 centimeters by 2 centimeters to find the volume. 4 times 2 is 8, and 8 times 2 is 16. So the volume of this prism is 16 cubic centimeters. Check your work. Ready for a challenge? Let's try another one. This image represents the top face of a rectangular prism. If the prism is made of centimeter cubes, what is the area of this space? 2 centimeters times 2 centimeters equals 4 square centimeters. So that's the area of this space. The rectangular prism that sits below this space is layers of cubic centimeters. It has a height of 4 centimeters, so there are 4 layers of centimeter cubes. What is the volume of this prism?
The length is 2 centimeters, the width is 2 centimeters, and the height is 4 centimeters. So we can multiply 2 centimeters by 2 centimeters by 4 centimeters to find the volume. That's 16 cubic centimeters.
That's right. We can also multiply the area of the top, 4 square centimeters, by the height, 4 centimeters, to find the volume. So the volume is 16 cubic centimeters. Try this last one on your own. This time, we can't see the dimensions of the top face, but we know the area. What's the volume of this prism? Great work using different strategies to find the volume of rectangular prisms. Keep it going.
Welcome back to Zern Squad. Let's see who we're working with today.
I'm Zeph.
I'm Milan.
And we're in the Zern Squad.
Today we will solve a 2-part word problem about a rectangular planter, which is a box for plants to grow in. Let's start with part 1. Read the problem and imagine what is happening. Read and imagine what is happening in this problem. Jeffrey wants to make a rectangular planter that extends from the ground to just below his back window. The window starts 3 feet off the ground. 1. If he wants the planter to hold 36 cubic feet of soil, name one way he could build the planter so that it is 3 feet tall. Explain how you know. Note, assume all of the dimensions are whole numbers. What does Jeffrey want to do? So Jeffrey wants to build a rectangular planter under his back window. He wants the planter to hold 36 cubic feet of soil, so that's how much space the planter will take up. In other words, 36 cubic feet will be the planter's volume. What else does Jeffrey need to figure out before he can build this planter? What else does Jeffrey need to figure out before he can build the planter? Which dimension does Jeffrey already know? Reread the problem. What will be the height of Jeffrey's planter? Jeffrey wants to make a rectangular planter that extends from the ground to just below his back window. The window starts 3 feet off the ground. 1. If he wants the planter to hold 36 cubic feet of soil, name one way he could build the planter so that it is 3 feet tall. Jeffrey needs to figure out what the planter's dimensions will be. We already know the height will be 3 feet, so that the planter will extend from the ground to just below the window that is 3 feet higher than the ground. Let's show this. Trace over the prism in your notes to represent Jeffrey's planter. Label what we know and use a question mark for the parts we don't yet know. Solve this in your notes. Jeffrey wants to make a rectangular planter that extends from the ground to just below his back window. The window starts 3 feet off the ground. If he wants the planter to hold 36 cubic feet of soil, name one way he could build the planter so that it is 3 feet tall. Explain how you know. Trace over the prism to represent Jeffrey's planter. Then, label what we know and use a question mark for the parts we don't yet know. We can draw a rectangular prism to represent the planter. We can label the height. It's 3 feet. We don't know the length or the width yet, so we can label these dimensions with question marks. And the volume is 36 cubic feet, so we can label that here. Check your work. What is the problem asking us to figure out? The problem tells us to name one way Jeffrey could build the planter. In other words, we need to figure out what Jeffrey can make the other dimensions so that the planter will meet his needs. Solve in your notes to show how Jeffrey can make his planter. Make sure to explain how you know. Solve for the other dimensions. Then explain how you got your answer. Note, assume all of the dimensions are whole numbers. It's time to talk to the Zern Squad about their strategies for solving. What did you try, Zeph?
I know volume is length times width times height. We know the planter's height is 3 feet, so I used guess and check to help me solve for the missing dimensions.
That works. How did you approach this, Milan?
I thought of the volume as area times height. I solved for the area first, then figured out the length and width.
Nice idea. Remember, it's okay if you solve differently than the Zern Squad, as long as you explained how you got the correct answer. So, which explanation do you want to hear?
I already knew the volume and the height of the planter, so I put those numbers in my equation. Then I had to figure out the length and the width. I used guess and check to see what numbers I could multiply to get 36. 36 is a pretty low number, so I thought I should multiply 3 small numbers. First, I tried 2 times 2 times 3. That equals 12, which is way too low. So next, I tried 4 times 4 times 3. And I got 48. That's a little too high. So then I tried 4 times 3 times 3. That equals 36, which is the volume Jeffrey wants. Now I need to explain my answer. I knew Jeffrey wanted to build a planter with a height of 3 feet and a volume of 36 cubic feet. I used volume equals length times width times height and figured out that the length could be 4 feet and the width could be 3 feet.
Nice work. Zeph showed you one of the correct answers. A prism with a height of 3 feet and length and width of 6 feet by 2 feet, or 12 feet by 1 foot, would also be correct. Check your work. Note, 6 feet and 2 feet, or 12 feet and 1 foot, are also correct for the length and width.
I already knew the volume and height of the planter, so I put those numbers in my equation. Then I used this equation to find the area. I divided 36 by 3 and got 12 square feet. So any two numbers that would give me that area would work for the base of Jeffrey's planter. I used 4 and 3 since 4 times 3 equals 12. I could have also used 6 and 2 or 12 and 1 since they have a product of 12 too. Now I needed to explain my answer. Since Jeffrey wants to build a planter with the height of 3 feet and a volume of 36 cubic feet, the base of this planter should have an area of 12 square feet. I drew a planter with the length of 4 feet, a width of 3 feet, and the height of 3 feet.
Nice job on part 1. Now let's expand on what we've done. Read part 2 and imagine what is happening. Jeffrey wants to make a rectangular planter that extends from the ground to just below his back window. The window starts 3 feet off the ground. 1. If he wants the planter to hold 36 cubic feet of soil, name one way he could build the planter so that it is 3 feet tall. Explain how you know. 2. Jeffrey needs another planter that holds double the volume. Should he double all of the dimensions? Explain why or why not. Include a drawing in your explanation. Jeffrey wants the new planter to have Jeffrey wants to double the volume. Reread the problem. Which expression will help you find the volume of the new planter? Jeffrey wants to make a rectangular planter that extends from the ground to just below his back window. The window starts 3 feet off the ground. 1. If he wants the planter to hold 36 cubic feet of soil, name one way he could build the planter so that it is 3 feet tall. Explain how you know. 2. Jeffrey needs another planter that holds double the volume. Should he double all of the dimensions? Explain why or why not. Include a drawing in your explanation. Reread the Jeffrey wants to make a new planter that will have double the volume of the first planter. So double the volume, or 36 times 2, is 72 cubic feet. Should he double all of the dimensions to get this new volume? Solve in your notes, and make sure to explain your answer using words and a drawing. Record the equations and solve. Then explain your answer using words and a drawing. Check your work. Should he double all the dimensions? Why or why not? There are a lot of different ways to approach this problem. Let's see 2 of these ways. What did you do, Zeph?
I decided to double the dimensions and solve for this volume. That way, I could see if it was equal to 72 cubic feet.
Good thinking. How did you solve, Milan?
I drew a second identical prism to show what it looks like when we doubled the value. Then I used this to help me think about what the question is asking.
Which explanation do you want to hear?
I wanted to figure out if doubling the dimensions would be the same as doubling the volume. First, I made a new prism to show what this would look like. I doubled the length. 4 times 2 is 8. Then the width. 3 times 2 is 6. Then the height. 3 times 2 is 6. And drew a prism with these dimensions. I thought that this seemed to be more than double this volume, but I multiplied just to be sure. I solved 8 times 6 times 6. And got 288 cubic feet. That's way more than double the volume. So, Jeffrey should not double all of the dimensions, because if he doubles all of the dimensions, the new volume will be larger than he needs.
We know Jeffrey wants to double the volume, so I drew 2 of the prisms next to each other to represent 2 times the volume. And I realized that I only doubled 1, not all 3 of the dimensions to get double the value. I checked my work by multiplying the new dimensions. 8 times 3 times 3 equals 72 cubic feet. So my answer checked out. Jeffrey should not double all the dimensions. He only needs to double 1 dimension in order to double the volume.
Way to work through some tough problems about volume. Now, show what you know in the Tower of Power.